In this algebra topic video, I will walk through the example of solving a rational equation, and I'm going to do this same one problem twice with two different methods, and after that I'll leave it to you to decide which of those two methods makes the most sense to you and which of those two methods do you want to use going forward. Here's the first method. The first method is I'm going to get the least common denominator. I have three pieces. I've got three different denominators. I'm going to use those three denominators to get a least common denominator. And after that, watch what I'm going to do. If here's a fraction practice that we have. If we have some value over a common denominator added to some value, some other value over the common denominator, and that's equal to something with a common denominator. You see, we could add the A and the B. When this denominator is the same and I cross multiply, watch what happens. 7 times A plus B would equal 7 times C. Divide by 7, and what do I have? This A plus B equal to C. So do you see, if I were to go back, let me highlight this. If I were to go back to the start, what do we have? A plus B equal to the C. So if I have a common denominator, that's the key. You've got to have the common denominator. If I have a common denominator, then I can just eliminate those denominators. I can ignore the 7s. It doesn't matter what the denominator is. When we have an equation, the denominators are all the same. We can just say the top plus the top equals the top, right? That's what we're going to use to solve this equation, this first method. I'm going to get a common denominator, and after I have a common denominator, I will just eliminate the entire denominator and solve from the numerators. Here's the common denominator. We need for the common denominator an x plus 5. So here's our x plus 5. And then when we move to the second fraction, we need an x plus 5 and an x minus 2. We already have the x plus 5, so we need to include also the x minus 2. And then for the third fraction, we need an x minus 2. We already have that x minus 2. So we can see that the common denominator is going to be x plus 5, x minus 2. I'm going to build that common denominator, and I'm going to use a red pen. I'm going to build that common denominator for all three fractions so they have a common denominator. But do you see what I've done? And I'm doing this with a red pen. I would encourage you to pause the video and get a highlighter or a red pen or something that stands out on your paper very clearly so that you can recognize that the piece we inserted, the way we've changed the fractions, is with the x minus 2 and the x plus 5. Because what I need to do next to counter that is insert that in the numerator, like this. So here's our equation with the common denominators. Once I have that common denominator, I can eliminate all those denominators. Now, if you're not comfortable with just crossing out those denominators, not understanding why, rewind the video, go back again to what I did over here in the top right with the A over 7 plus B over 7 equals C over 7 to prove to yourself this fact that if this equation is true, then the equation A plus B equals C is also true. Just a property of fractions that works. But now I'm ready to solve this equation, and I'm just going to solve with the numerators. Now on your paper, I wouldn't do this. I would just rewrite it. But on mine, since I have such a nice easy eraser, and we have the function of being able to rewind to see what was here, I'm going to just erase that, right? So this is what we're left with. Okay. Now, let's solve from here. The next thing we're going to do is multiply or FOIL, and this is now a review of previous chapters. So we'll factor, or we'll multiply this out, first times first, outside times outside, inside times inside, last times last. And for this example, we're going to distribute, so x times x plus x times 27. It's x squared plus 27x minus first times first, outside times outside, inside times inside, last times last. But look at what happens. And maybe you recognize this right off the bat, that this was the difference of two squares, because these two middle terms are going to cancel, right? 5x minus 5x. Now, watch something really important. This is how most students approach this problem, and this is incorrect. Do you see how this subtraction was written? What were we supposed to be subtracting? Supposed to be subtracting that entire product. So we should be subtracting x squared and subtracting negative 25. Here's a common mistake students make, is ignoring that minus, but this minus needs to distribute to each of the two pieces that we got when we multiplied. So this minus, here's a good approach. Change it to adding, and then this x squared and the negative 25 both change their sign. So minus x squared minus negative 25 becomes minus x squared plus 25. Watch out for this plus 25 right here. That's one of the most common mistakes students make with this example. All right, next, what we're going to do is see that the x squared and minus x squared are going to cancel out, right? X squared minus x squared cancel out, because x squared minus x squared is just 0. So we have on the right side here, we have, oh, and do you know what? Did you see this? I was just looking at this trying to think what was off. I had a glare on my tablet and I overlooked that this is a minus here. Maybe you caught that. I'm going to fix that before we go on. The reason I caught that is because as I'm going along, I'm always checking my work, and I notice, oh wait, that's supposed to be a negative. So I apologize for that. Hope you caught that already. But this should have been x times, when we factor out x, so x squared minus 27x, and we divided by x, should have been x minus 27 here, right? So, okay, let's continue here. So this will be a minus. And what we have on the left, we could simplify. X squared minus x minus 2. And on the right side, we have x squared minus 27x and plus, oh, we already eliminated the x squared, right? Here, I'll finish writing this. Minus x squared plus 25. And we've canceled out this x squared minus x squared. So we just have the minus 27x plus 25. To solve a quadratic equation, now this is a quadratic because it's a square, an x squared, what we're going to do is set everything equal to 0 and then factor. So to set it equal to 0, I want to get a 0 on one side or the other. It's going to be easiest to get a 0 on the right. So I'm going to add 27x. So I'll do that to the other side also. I'm going to subtract 25. I'll do that to the other side also, so that we can get a 0 on the right side of the equation. On the left, we have x squared minus x plus 27x is plus 26x. Minus 2 minus 25 is minus 27, and so we've got it. Do you remember how to solve this from here? I know it's a lot of steps here. This was a pretty involved problem, but what we've got to do next is factor this. So we'd have x minus 1 and x plus 27. Do you see how I factored that? I was looking for two numbers that when I add, I get 27, and when I multiply, I get negative 27. And the two numbers that multiply to 27 are 1 and 27. To make them negative, to make this product negative, one of these two has to be negative. If I make the negative 1, if I make the 1 the negative, then I have 27 minus 1 is positive 26, and then negative 1 times 27 is negative 27. So we've got that factored. The last step, I know this has a lot, right, is to set each of these two factors, the x minus 1 and the x plus 27, set each of them equal to 0. When I make that equal to 0, I can solve for x to get x equals 1. Subtract 27 from both sides to get x equals negative 27, and there's our answer. I know this wasn't an easy example, but you can do this. It just will take a little bit of practice. Walking through the steps, what did we do? We got a common denominator. Once we got the common denominator, it was here. We eliminated it and then just worked from the numerator. All right, let me show you one other way we could have approached this example. The other way, again, we start with the common denominator, but what we're going to do differently here is we're going to multiply every piece by the common denominator. So we'll multiply the entire fraction by x plus 5 and x minus 2. Watch how that looks when I do that. And I'm going to do this with a different colored pen. I have the original problem is written with black. I'm going to insert in the, and you know, let me add the parentheses first here to everything. I'm going to insert in the x plus 5 multiplied by x plus 5, x minus 2 all the way across. Once you have that common denominator all the way across, reduce x plus 5 over x plus 5 is 1, x plus 5 over x plus 5 is 1, x minus 2 over x minus 2 is 1, x minus 2 over x minus 2 is 1. Do you see what we have here? Does that look familiar? Let me highlight out what we have. We now have x plus 1 times x minus 2 equals x minus 27 minus x minus 5, x plus 5. It's the same thing we had on the previous page. So from this point right here, we just continue and do the same process again. I'm going to go ahead and do that one more time. You could stop the video here if you understood what we did from that step, but I'm going to just go walk through it one more time because I know that it was pretty involved. First, I'm going to multiply this out. So I FOIL, simplify, distribute, and simplify. Being careful with this minus, that we're going to subtract the entire product, x squared minus 25. Well, now it's a difference, but it was a product here with the x squared minus 5x plus 5x minus 25. But be careful with that minus, and I'm still going to call out another color here. Change that to adding the opposite. And next I will combine like terms. So I've got x squared minus x minus 2. Nothing combines there. But this x squared cancels out. Minus 27x plus 25. Subtract 25 from both sides. Subtract negative 27 from both sides, or in other words, add 27x. So we have x squared plus 26x minus 27 equals 0. Next, I'm going to factor that. So to factor it, looking for two numbers that when I multiply, I get negative 27. When I add, I get positive 26. Those numbers are 27 times negative 1. 27 times negative 1 is negative 27. 27 plus negative 1 is 26, positive 26. So I know that the two factors are going to be x plus 27 and x minus 1. And from there I can solve by setting each factor to 0. Subtract 27 from both sides to get x is negative 27, or the other factor, x minus 1 is 0. Add 1 to both sides to get x is 1. And there we have it, negative 27 and 1. I hope you found this video helpful, one of the two methods. And if you need to, rewind the video and watch it again a few times until you feel really confident about each of the steps of this problem. One struggle with this problem is that it's not just solving the rational equation, it's then also adding in that skill of solving a quadratic equation.